Hey guys, so in this video I'm going to introduce to you what an augmented matrix is. An augmented matrix is the combination of system of linear equations, and this, the top row, would be an example of one linear equation. So when we have problems where it requires more than one linear equation, we would put them into a matrix to see if we could find a solution for it. And there are three different cases, which I'll get to you in a bit. But those three cases are: you could have infinite many solutions, no solutions, or a unique solution. Alright? So how you would go about writing out this augmented matrix is as follows. Alright, so let's start. Okay. I'm just making it big for you guys. Okay, so you take the coefficients of each of the linear equation, for instance, 3, 6, -6, -9. And you'd go down the next row. This would be a 1. So 1, 3, once again, 1, -5. Go down a row, 2, 5, 2, and 2 again. -2, 7, -5, and -7. Alright? And so this we would count as the coefficient matrix, because these are what this section here is the coefficients of each of the linear equations, hence why we call it the coefficient matrix. Then we draw a line here, and we'd write the solutions for each linear equation, which is 63, 36, 30, and -64. This here, this portion, we would count as the constant matrix, because these are the constants for each of the linear equations. And in total, this whole thing is called the augmented matrix. And in later videos, I will show you how to use methods to get solutions for this. But what you need to know for now is, if you use Gaussian elimination to reduce the matrix, you can either get one of these three solutions. Alright? And I'm going to write this out for you really quickly. Okay. So, if you end up with 0, 0, 1, 0, and this is meant to be a 0, and this is meant to be a 1 in your matrix, this would lead to no solution. The reason being is because I'm pretending that this could be any number of rows and any number of columns, and to this particular matrix it would have 4 rows and, this many columns, right? So what I'm trying to get at here is, if all these numbers, if this was 0, 0, 0, and 0, is it possible for it to equal 1? No, because if you put 0 in front of here, 0 in front of you, 0 in front of you, 0 in front of you, no matter what number you replace x with, it would still all be 0 plus 0 plus 0 plus 0, and it cannot equal 1. Because if it equals 1, it means the whole world's gone crazy. Hence why there is no solution in this. Alright? And for infinite many solutions, okay, once again I'm going to draw this out, simple matrix, is we've got a 1 here, any number here, or 0 here, and 1 here, 1 here. Alright? And these are whatever numbers you get them to. Alright? The reason this is infinite many solutions is because when we're trying to find for variables, this would be x1, x2, x3, and x4. Because if you look at this is x1, x2, x3, and x4. Okay, so they come from these sections because they're just coefficients of it. So, if this doesn't have a number and it's 0, we would have to substitute it with a variable because we can't just say x2 is nothing. So we'd substitute it with a variable, and once you add any kind of variable like an r, s, or t, you would have, like, it would make the solution infinite many because r could be any number. And finally, the last kind of solution is a unique solution, which involves 1, 2, 3, 4, 1, 1, 1, 1. Basically, these are all zeros, and what that means is x4 in this case, just for example sakes, equals 1. So x4 equals 1. In this case, x3 equals 1. And you're not always going to get 1, so this could be another number. This could be 2, for instance, and x3 equals 2. And every number has its own unique thing, individual to only itself. And that's what makes it unique. So x2 equals 1, and x1 equals 1. And it all has its own solution to it. And that's what an augmented matrix is used for, to find out which type of solution you have, and that's how you solve the system of linear equations. Alright, well, thank you guys for watching this video. I hope you liked it, or it was helpful to you at least, and hope there's more coming. Thanks.